Welcome. Today we take few problems on maxima and minima. So today's first problem is find the minimum value of fx is equal to e to the power x to the power 4 minus x cube plus x square is. The options are 2e, e, 1 by e, and 1. The problem was given in West Bengal Joint Entrance Board in the year 2009. Here the problem is very straightforward. One function is given to find its minimum value. We have to differentiate it. So f dash x is equal to e to the power x to the power 4 minus x cube plus x square into derivative of that part 4x cube minus 3x square plus 2x, so that it is equal to, from there x can be taken common. Okay, first of all e to the power x to the power 4 minus x cube plus x square plus x into 4x square minus 3x plus 2. For maximum or minimum, first derivative, that is f dash x, should be 0. So f dash x is equal to 0 gives e to the power into, this is into x into 4x square minus 3x plus 2 is equal to 0. So it has three factors, 1, 2, 3. Now this cannot be 0. Exponential function in finite range cannot be 0. So that only possibility is that x into 4x square minus 3x plus 2 is equal to 0. Either x is equal to 0 or this is equal to 0. But its discriminant is minus 3 whole square minus 4ac, 9 minus 32 negative. So it has no real root. So only possibility is that f dash x is equal to 0, we get x is equal to 0. Now let us now see whether at that point it is maximum or minimum. On second derivative, f double dash x is equal to e to the power x to the power 4 minus x cube plus x square into its derivative, that is again this one, this, so it will be 4x square minus 3x square plus 2x whole square. This plus, actually from here I differentiate, its derivative is e to the power that into its derivative is this, so that plus e to the power x to the power 4 minus x cube plus x square into derivative of that. I mean, just 1 minute. Eta, then this whole square. Now, this one into derivative of that means it is 12x square. Okay, I write it there into 12x square minus 6x plus 2. Now at x is equal to 0, this become 1. This is positive. This is positive because it is whole square. This is positive into this is 2 at x is equal to 0. So at x is equal to 0, f double dash x is positive, so that the function attains its minimum value at x is equal to 0, and minimum value is e to the power 0 minus 0 plus 0, that is e to the power 0, that is 1. So option is 1. Now next, problem is maximum value of y is equal to 5 by 2 minus mod of x minus 5 by 2. It is a mod function and we have to find its maximum value. Answer is 5 options: 5, 6, 4 and 5 by 2. This is a mod function. To get maximum or minimum value, we have to differentiate it. But from here, from the construction of the given function, it is clear that mod of x minus 5 by 2, it is mod function, so greater than or equal to 0. So clear that y is equal to either when this is 0, it is 5 by 2, and when it is greater than 0, it is less than 5 by 2. Either 5 by 2 or less than 5 by 2. No, less than or equal to 5 by 2. So we have to find its maximum value. So value of y, that is this function, is either 5 by 2 or less. Therefore, its maximum value is 5 by 2. This one. Without any calculation, we do it. Now, next problem. Maximum value of fx is equal to x by 8 plus 2 by x in the range 1 to 6. Options are 1 to 6, closed interval, 17 by 8, 2, half, and 17 by 12. And that problem was given in the year 'Acha, one thing I discuss before solving the problem. Suppose in an interval, say AB, A to B, one function is given like that. It is A, it is B. In that interval, one function is given. And we can find at what point its derivative vanishes. That is critical point. That is where it is either maximum or minimum. From drawing, it is clear that at that point, at this point, its derivative vanishes. Now, from figure, suppose this point is say C. So from A to C, the function decreasing. At C, it attains its minimum value. After that, from C to B, it increases. Whenever one x, that is a range of x is given, in that case, we have to think in that way. What is that? Now, from A to C, it is decreasing. So in that range, its maximum value is at that point, at A, the initial point. Very easily from there we can find its maximum value. Value at that, FA can be obtained. It may be maximum here. Achha. Here it is minimum. After that, it increases. It increases. So steadily it increases means maximum value of that part is at that point. And because it is steadily increasing there. So at B, so it is maximum for that part. So AB is another possible answer of maximum value. Now very easily from there we can find FA and FB, and we have to accept the this one which is more between this and that would be the maximum value of that type of function in a given interval. So whenever one interval is given, so we have to find its increasing part, its decreasing part, and so on. So differentiating that, f dash x is equal to 1 by 8 minus 2 by x square. So f dash x is equal to 0 gives, it is x square minus 16 is equal to 0. That is x is equal to plus minus 4. Minus 4 is not within that range. So actually we have to consider x is equal to 4. At that point, that is from this point is A, 1. 1, this is 4. So 1 to 4, let us see whether it is increasing or decreasing. So between, it is actually for all values of x, it is at 4, it is 0. And before that, say x is equal to 1, it is negative. X is equal to 2, it is negative. So for all values of x, f dash x negative in 1, 2. So the function is decreasing in the range 1 to 4. So decreasing. So its value, maximum value, must be at the point x is equal to 1. So maximum value for that range 1 to 4, f max in 1 to 4, it is equal to, we have to put 1 there, it is 1 by 8 plus 2. This is 17 by 8. 17 by 8 is the maximum value of that function in the range 1 to 4 where it is decreasing. Next, from 4 to 6, at 4 it becomes 0, after that it becomes negative. So f double dash x, I mean f dash x is negative. F dash x is that, so 1 by, it is at 4, it is at 2. It is now, f dash x is now positive in the range 1, 4 to 6. Because you see, at 4 it becomes 0, and at 6, 1 by 8 minus 2 by 36. So it is more than that, positive. So it is positive over there. So it is increasing function. So in that range, it increases from this to that. And because it is increasing, its maximum value must be at the descent point, that is at x is equal to 6. So for that range, f max in 4 to 6 is equal to, at 6, that is 6 by 8 plus 2 by 6, so that it is equal to 3 by 4 plus 1 by 3, 9 plus 13, that is 9 plus 4, that is 13 by 12. So here it is 13 by 12, at that point it is 17 by 8. Between these two maximum values, this is more than that. So its maximum value is 17 by 8 for this one. So mind that this type of problem is very, very important. So sometimes we cannot find the straightforward which one is maximum, which one is minimum, but actually we have to calculate if it is a increasing function, then its end point, means other end point, is the maximum value. If it is decreasing, then its initial point is the maximum value. Few more problems of that type I solve. Next problem is the point in 0 to 2 pi where fx is equal to e to the power x sin x has maximum slope. So we have to find the point where this function has maximum slope. This is function, but this is not slope. Therefore, we first of all we have to find its slope. Slope is nothing but f dash x. Then ddx of fx, that is e to the power x sin x plus e to the power x cos x. It is equal to e to the power x sin x plus cos x. Oh, sorry, I have forgotten to give the options. Which one? Options are 3 pi by 2, pi, pi by 4, and pi by 2. And that problem was given in we have to find the point within that where this function had maximum slope. Slope of the function is m is equal to that. So we have to find its maximum value. Now for that purpose differentiate dm dx. E to the power derivative of e to the power x is this into sin x plus cos x plus e to the power x into derivative of that. It is cos x minus sin x is equal to e to the power x taking common, sin x cancels into 2 cos x. So dm dx is equal to 0. That gives us cos x is equal to 0. Because this cannot be 0, exponential function in finite range, it cannot be 0. So cos x is equal to 0. So cos x is equal to 0 means x is equal to pi by 2 and 3 pi by 2 within that range, 0 to 2 pi. Now let us see at what point it is maximum. So for that purpose d2m dx2 is equal to 2 into e to the power x cos x, its derivative is that, then 2 into e to the power x into derivative of cos x is minus sin x is equal to 2 e to the power x cos x minus sin x. Now at first critical point is this. At that point pi by 2, let us see its sign. It is 0, it is negative. So altogether it is negative. So it is maximum there. So it is maximum at x is equal to pi by 2. Let us find this also. At 3 pi by 2, what happens? At 3 pi by 2, this is negative. Sin 3 pi by 2 is negative, but before that one negative is there. As a whole, it is positive. So it is minimum there. Minimum at x is equal to 3 pi by 2. So that the slope is maximum at the point x is equal to pi by 2. This one is correct option. Sure. Now our next problem. Maximum value of the function x into y subject to x plus y is equal to 8. It is given in the year. So options 2, 6, 16 and 8. Here we have to find the maximum value of that subject to x plus y is equal to 8. Means x and y are such that their sum is equal to 8. In fact, it is function of two variables x and y, but at this level it is not possible to find the maximum value of two variable functions. From there we can find value of y in terms of x and put it there. Then actually z, this function is z, say x into y means 8 minus x. So 8x minus x square is the function whose maximum value to be determined. For that purpose, dz dx is equal to 8 minus 2x. For maximum or minimum, dz dx is equal to, this is equal to 0, means 8 minus 2x is equal to 0 gives x is equal to 4. So at x is equal to 4, the function is either maximum or minimum. To be sure, double derivative is minus 2, negative for all values of x. For x is equal to 4 also it is negative. So this is maximum at x is equal to 4, and maximum value is z max is equal to 8x means 32 minus 16 is equal to 16. So 16 is the answer. Next, maximum slope of the function y is equal to minus x cube plus 3x square plus 2x minus 27. Maximum slope of the function, and options are 1 by 5, 5, 1 by 3 and 1. That problem was given in the year In this case, we have to find maximum slope of that, not maximum value of that. So slope of this function is nothing but dy dx. Minus 3x square plus 6x plus 2. And let it be m. Slope is m. M is this, slope is this. We have to find its maximum value. For that purpose, dm dx, calculate dm dx. Minus 6x plus 6. So for maximum value of m, dm dx is equal to 0. It gives x is equal to 1. Double derivative, d2m dx2 is equal to minus 6. This is negative for all values of x. In particular, x is equal to 1, this is also negative. So at x is equal to m, first of all, we see that we see that x is equal to 1 is the critical point, that is the function is maximum or minimum if exists, that is at the point x is equal to 1, not other points. So x is equal to 1 is the critical point. And now we see that its double derivative is negative there. So the function uh, attains its maximum value at the point x is equal to 1. And maximum slope, m is slope, m max is equal to minus 3 plus 6 plus 2, that is 5. So 5 is the maximum slope of that curve. So this is answer. Now our next problem. For the curve y is equal to x into e to the power x, which one is correct? Number 1, maximum at x is equal to 1, minimum at x is equal to 0, minimum at x is equal to minus 1, or this is minus 1, and the maximum at and that problem was given in the year same examination WBJE 2007. So here y is equal to x into e to the power x, that curve is given, that function is given. We have to determine for that curve which one of the following 4 is true, whether it is maximum at x is equal to minus 1 or so on. For that purpose, we have to find either maximum or minimum. We have to find derivative. So dy dx is equal to 1 into e to the power x plus x into e to the power x is equal to e to the power x into x plus 1. For maximum or minimum, dy dx should be 0. That is, it gives us e to the power x into x plus 1 is equal to 0. But e to the power x exponential function cannot be 0. So only possibility is that x is equal to minus 1. So the only critical point is x is equal to minus 1. Now we have to rather let us see at x is equal to minus 1, the function is maximum or minimum. For that purpose, we have to find double derivative, and double derivative dy dx, d2y dx2, it is derivative of that, it is e to the power x, its derivative is this, into x plus 1 plus its derivative is 1 into e to the power x is equal to e to the power x into x plus 2. So at x is equal to minus 1, d2y dx2 at x is equal to minus 1, this become minus 1, this is positive. So it is equal to e to the power minus 1 into 1. So positive. So the function, this function is minimum at the point x is equal to minus 1. Next, the point on x square is equal to 2y, which one is nearest from 0, 3? Options 1, 2. Second point is 2, 2. 3, 9 by 2, 0, 0. So this is a curve, x square is equal to 2y, and that it is of that type. It is a parabola, and 0, 3 is a point. 0, 3 is a point over there. 0, 3. We have to find the minimum distance of that point from that curve. Suppose this point on the curve is that. Take a parametric representation of that point. If x is equal to t, 2y is equal to t square, so y is t square by 2. You see, this point must satisfy it. So we have to find that length. It depends on t. We have to find value of t so that it is minimum there. Suppose d square is the distance from 0, 3 to that. It is equal to square of the distance. It is equal to t minus 0 whole square plus t square by 2 minus 3 whole square. So square of the distance is that. If distance is minimum, square of the distance will be minimum. Let it be L. L is equal to t square plus t square by 2 minus 3 whole square. To find its maximum or minimum value, dl dt. Because L is a function of t only. It is equal to 2t plus 2 into t square by 2 minus 3 into derivative of that is 2t by 2 into t. That's all. So it is equal to 2t into 1 plus t square by 2 minus 3. That is 2 plus t square by 2 minus 2 derivative. So derivative for maximum or minimum length distance, derivative dl dt must vanishes. Therefore dl dt is equal to 0 gives us 2 plus t square by 2 minus 2. Oh, just 1 minute. dl dt is equal to just 1 minute. dl dt is 2t plus 2 into that into t. That is 2t into 1 plus, that is this is t, 2t into t square by 2 minus 2. So dl dt is equal to 0 gives us either t is equal to 0 or t square minus 4 is equal to 0. T is equal to plus minus 2. T square minus by 2 minus 2, that is t square minus 4 by 2 is equal to 0, that is t is equal to plus minus 2. So we get three critical points. Here four options are there. Let us calculate whether which one is for maximum or which one is for minimum. T is equal to 2 at the test for t is equal to 2. Then for that purpose d2l by dt2 is equal to 2 into t square by 2 minus 2 plus 2t into t. Its derivative is 2t by 2, that's all. So t. So now at the point d2l dt2, at the point t is equal to 2, it is actually, this becomes 0 and it is positive. So distance is negative at the point t is equal to 2. No need of testing for t is equal to 0, etc. Oh, t is equal to minus 2, no need of testing for that. Our point is t and t square by 2. At t is equal to 2, the point P is 2 and 4 by 2 means 2. So I got this answer, and d2l dt2 at t is equal to 0, this is positive, this is 0 and this is negative, so it is not minimum there. Once again I am repeating, at t is equal to 0, this is double derivative is, this becomes 0 and this is 0, so minus 2, so negative, so not minimum. So minimum value at is at t is equal to 2, that is point is 2, 4 by 2, that is 2, 2, 2. So 2, 2 is the answer. So today is up to this. My request, if you feel that this is helpful for you, so please like it, share it and subscribe it. Thank you.